In this video, we will look into electrosurgical unit devices. Let's start the video by looking at where it all began. Development of the first commercial electrosurgical device is credited to William T. Bovee, who developed the first electrosurgical device while employed at Harvard University. The first use of an electrosurgical generator in an operating room occurred on October 1, 1926 at Peter Bent Brigham Hospital in Boston, Massachusetts. The operation, a removal of a mass from a patient's head, was performed by Harvey Cushing. Let's look into the principle of electrosurgery. Often, electrocautery is used to describe electrosurgery. This is incorrect. Electrocautery refers to direct current, electrons flowing in one direction, whereas electrosurgery uses alternating current. Modern-day electrosurgery is the utilization of alternating current at radio frequency levels. During electrocautery, current does not enter the patient's body. Only the heated wire comes in contact with tissue. In electrosurgery, the patient is included in the circuit and current enters a patient's body. Electrical current flows when electrons from one atom move to an adjacent atom through a circuit. Heat is produced when electrons encounter resistance. For current to flow, a continuous circuit is needed. In the operating room, the circuit is composed of the patient, the electrosurgical generator, the active electrode, and the return electrodes. The electrosurgical unit is the source of the voltage. Electrical surgery is converted to heat in tissue as the tissue resists the flow of current from the electrode. Three tissue effects are possible with today's electrosurgical units: cutting, desiccation, and fulguration. Achieving these effects depends on the following factors: current density, time, electrode size, tissue conductivity, and current waveform. Now let's learn all about the electrode modes in electrosurgical units. Let's begin with the bipolar electrosurgery. In bipolar electrosurgery, both the active electrode and return electrode functions are performed at the site of surgery. The two tips of the forceps perform the active and return electrode functions. Only the tissue grasped in the forceps is included in the electrical circuit. Because the return function is performed by one tip of the forceps, no patient return electrode is needed. Bipolar electrosurgery operates regardless of the medium in which it is used, permitting coagulation in a fluid environment, a great advantage when attempting to coagulate in a wet field. As a result, bipolar electrosurgery is often referred to as wet field cautery. The second mode is monopolar electrosurgery. In monopolar electrosurgery, the active electrode is placed at the surgical site. The patient return electrode, also known as a dispersive pad, is placed somewhere else on the patient's body. The current passes through the patient as it completes the circuit from the active electrode to the patient return electrode. The function of the patient return electrode is to remove current from the patient safely. A return electrode burn will occur if the heat produced over time is not safely dissipated by the size or conductivity of the patient return electrode. Modern electrosurgical machines have built-in safety features to prevent burns from occurring due to poor contact between the patient and the return electrode when using the monopolar mode. The third mode is fulguration mode in electrosurgery. In fulguration mode, the electrode is held away from the tissue so that when the air gap between the electrode and the tissue is ionized, an electric arc discharge develops. In this approach, the burning to the tissue is more superficial because the current is spread over the tissue area larger than the tip of the electrode. Under these conditions, superficial skin charring or carbonization is seen over a wider area than when operating in contact with the probe, and this technique is therefore used for very superficial or protrusive lesions such as skin tags. Ionization of an air gap requires voltage in the kilovolt range. Three tissue effects are possible with today's electrosurgical units: cutting, desiccation, and fulguration. Achieving these effects depends on the following factors: current density, time, electrode size, tissue conductivity, and current waveform. Let's look into the components of an electrosurgical unit. An electrosurgical unit, or ESU, consists of a generator, a handpiece, and grounding electrodes. The device is controlled using a switch on the handpiece or a foot switch. ESU generators are able to produce a variety of waveforms. As waveforms change, so will the corresponding tissue effects. Using a constant waveform, like cutting, the surgeon is able to vaporize or cut the tissue. These waveforms produce heat very rapidly. Using an intermittent waveform like coagulation to the generator to modify the waveform so that the duty cycle is reduced. This interrupted waveform will produce less heat instead of tissue vaporization. A coagulum is produced. Cautery electrodes are available in different shapes and sizes depending on the surgeon's requirement. Electrosurgical pencils can be operated either by hand or foot and are reusable and also come in disposable variants. ESU pencils give surgeons the ability to control cutting and coagulation settings by buttons or switches. The types of electrodes are blade electrode, needle electrode, ball tip electrode, blunt electrode, precision electrode. There are two types of grounding pads in ESU. One is disposable, and the second one is reusable pads. Disposable grounding pads are made of a plastic base material that is covered with a metal film that serves as the actual electrode surface. Covering the metal surface is an adhesive gel layer that can easily be attached to the patient's skin. Also referred to as single-use pads or sticky pads, the disposable grounding pad must be large enough to keep the current density low to prevent heat buildup that might result in a burn under the pad. Although cost-effective and versatile, disposable grounding pads can cause patient skin problems such as hypersensitivities, allergies, and even removal of layers of skin when the pad is removed. Additionally, many practitioners are concerned with the wastefulness of disposable pads. Advanced technology has introduced the reusable pad that reduces and in most cases eliminates the negative results of using disposables. An electric foot switch works like any other electric switch. Inside the foot switch, there are contact points. The wires of the foot switch are connected to the electric circuit of a device. When wired, normally open, the contacts within the foot switch are not touching. The electric circuit is not connected and the device is off. When the foot switch is compressed, the contacts will be closed, connecting the electric circuit and switching the machine to on. Let's look into the types of electrosurgery units. The two types of electrosurgery most commonly used are high-frequency electrosurgery and electrocautery. High-frequency electrosurgery refers to 4 different methods: electrocoagulation, electrodesiccation, electrofulguration, and electrosection. These methods involve high-frequency alternating current, which is converted to heat by resistance as it passes through the tissue. The result of heat buildup within the tissue is thermal tissue damage. These modalities are commonly used for hemostasis, debulking procedures such as rhinophyma excision, and treatment of benign and malignant skin conditions ranging from acrocordons to basal cell carcinoma. Electrocautery is a form of direct transference of heat to tissue. Instead of passing electrical current through the tissue, the current is used to heat a handheld element, which is then applied to the tissue. This form of electrosurgery is most commonly used for hemostasis and tumor destruction when high-frequency electrosurgery is contraindicated. Additional modalities of electrosurgery include electrolysis, which uses a chemical reaction caused by a direct current to damage tissue, and coblation, used for facial rejuvenation, which uses an electrical current to ionize a conduction medium such as isotonic saline. The ionized medium is then used to transmit heat to tissue. This was a simplified video on ESU. I hope you liked this video, and if you did, please give us a thumbs up and subscribe down below. And I'll see you guys in the next video.